leading the third wave of storage. How do we deliver class-leading IOPS, throughput, and latency, whether it's block, file, or object, in a 4-rack unit platform? How our unique hardware and software architecturally is materially different than the competition. We do big and fast really well, and we give our customers the flexibility and choice to deliver high performance, whether that's IOPS or throughput, whether that's block, file, or object. The world is evolving from monolithic applications to more cloud-like scale-out application. That's forcing the market to drive flexibility as this world is evolving. The world has changed from infrastructure being more monolithic to more scale-out or hyperparallel. Applications are moving to scale-out or hyperparallel applications, which is demanding consistent, predictable, scalable high performance at low latency, which of course drives the servers to scale out or become more hyperparallel, which is driving the storage to become more hyperparallel. These applications are starting small and growing big, and are driving the demand to separate performance of the application with capacity of the storage. And as the applications scale out, the servers scale out, and the storage is demanded to scale out, it's requiring the performance of DAS or direct attached storage and all the benefits of shared to get that consistent, predictable, scalable, high performance at ultra low latency. So as IT application infrastructures evolve from the scale up architectures to the scale out architectures, then the storage architectures of the world need to evolve to support this scale out world and this linear performance requirement of the scale out world. The typical storage controllers of today, our competition of the past several years, have been built on a storage-centric design. It started with storage, and how do I share and provide services for that storage to hosts? And they typically did that through a dual controller interface with limited numbers of ports. Well, to support this scale-out new world and the linear scalability required, Pavilion has a new way. And it's this network-centric design. The any-to-any connectivity that enables a multi-controller environment to enable that scale-out. Pavilion is more like a switch than it is like a typical storage array. We've evolved to support the scale-out world. So to understand how Pavilion is able to achieve such impressive performance numbers in such a dense form-factored solution of 4 rack units and over a petabyte of usable storage, we first have to understand the architectures of the typical all-flash array of today and what Pavilion has done differently. And so those architectures of today for the all-flash arrays is of course a set of SSDs, SATA or SAS, with some sort of internal bandwidth, with some controllers which speak to hosts out through ports running some sort of protocols. And by the very nature of SATA or SAS SSDs, there's one queue from the host all the way through to each one of the drives, resulting in some sort of IOPS with some sort of throughput, read and write at some sort of latency. So with the advent of NVMe, what did the typical all-flash array vendor do? Well, they replaced their SSD drives, SAS or SATA, with NVMe. And by doing that, they fundamentally improved the performance and latency of each one of their storage arrays to some degree. What that degree is, I don't know, but by the very nature, they made it better and faster. Some of those vendors also added a new modern protocol out to the host, NVMe over Fabric, which by its very nature allows multiple queues to each one of the hosts, with multiple queues all the way through into each one of the NVMe drives. Some of those people did that over fiber channel. Some of those people did that over Ethernet or InfiniBand. When you do it over Ethernet or InfiniBand, you have the ability to do RDMA or remote memory access right to the drives. Rocky is for Ethernet and RDMA is for InfiniBand. But the real question is, what did those vendors do in between that? Did they change the internal bandwidth? Did they change the number of controllers they had? Did they change the number of ports? Because by the very nature of NVMe, you've added incredible throughput for each one of the drives. So did you move the bottleneck somewhere else in that array? Did they do anything to their data management software to take advantage of the features of NVMe? Well, what Pavilion did was materially different because we started from ground zero. We started from the hardware and software built from the ground up to only support NVMe and NVMe over Fabric, all the way from the host right down to the drive. The result of that is a 4 rack unit system with over a petabyte usable of storage that results in 20 million IOPS, 120 gigabytes a second read, 90 gigabytes a second write, at 25 to 100 microsecond latency. Well, how did we do that? Well, everything was new. So we started with 72 NVMe drives and implemented 4 queues per drive. We started with a network-based design. We have a 6.4 terabit PCIe switch between our drives and our 20 active controllers. Not 2, 20 active controllers. Leveraging our 40 100 gigabit Ethernet or 100 gigabit InfiniBand ports, 40 ports. Leveraging the modern protocol of NVMe over Fabric, whether that's InfiniBand or it's Ethernet, whether that's RDMA or not. So we have multiple queues from the host, from each host through multiple controllers with an incredible bandwidth and of an internal switch to each one of the drives, coupled with software fundamentally built from the ground up to support NVMe and NVMe over Fabric. Later, of course, we added NFS and S3 protocols on top of our NVMe over Fabric. The result of this is incredible performance in a very, very dense form factor, again, built from the ground up to support NVMe and NVMe over Fabric. What we did differently was everything. As our customers say, this is one of the reasons we've made the impossible possible. The Pavilion architecture, whether that's our hardware or our operating system, is all built from the ground up to support NVMe and NVMe over Fabric. Every one of our independent controllers has its own memory, CPU, and ports. And each one of those independent controllers, which there are 20, runs a version of the Pavilion operating system, providing block, file, or object, and all the storage services associated with. So each one of those 20 independent controllers runs the Pavilion OS, managed by our supervisors. Every one of those controllers has its own private Ethernet network inside the box to enable them to communicate directly to each other, to work cooperatively to solve problems. So the ability for us to scale linearly out is our ability to add hardware linear cards or line cards that have 2 controllers on each. Start with 1, move with 10, which enables 2 to 20 controllers all working independently. That provides the flexibility and choice and the ability to start small and grow big. And by growing and scaling, performance, whether that's IOPS, whether that's throughput, all scales linearly. So as we talk about hyperparallelism, there's a couple approaches to that. Is to have a node and to scale those nodes horizontally from a storage perspective and have them clustered together. Pavilion has taken the approach with our unique architecture and unique software to have those independent controllers scale horizontally with inside a unique densely packaged form factor of 4 rack units. Whether that's block, file, or object, you see impressive performance across the board, starting small and growing big. Let's look at the competitive landscape as it relates to that. In the EMC Dell world of a PowerMax all NVMe, you can start small with a single brick and scale that to 8 bricks, enabling hyperparallelism. That's 2 racks of storage. NetApp can start small with a single AF800 and externally cluster those together up to 12 of those AF800s. Pure can start relatively small with an X90 with one direct flash tray and add a second direct flash tray. They have Pure FlashBlade that is more similar in concept to a Pavilion, where you can start with 1, 2, 3, 4 and add blades as it goes, or cluster them externally together. Or the Hitachi's new VSP 5000 can start with a single node and move up to 3 of those nodes, which are both 2 controllers in each one. But let's look at the difference. Pavilion delivers block, file, or an object in a 4 rack unit form factor at 20 million IOPS. Let's summarize EMC's platform. To get their 15 million IOPS, it takes 80 rack units, and you can get block and file in that platform. NetApp, they can scale up to 11.4 million IOPS relative to Pavilion's 20 million IOPS, takes 48 rack units. Pure's system can scale up to, they only measure in microseconds as they publish numbers, call it 150 microseconds to 1 millisecond. Everybody published their lowest. Ours is 25 microseconds. That's in 9 rack units, only doing block. If you want file and object for Pure, you have to add FlashBlade, and it can do file and object. And yes, it can move up to 150 gigabytes a second read in 48 rack units. So as you look at Pavilion's unique approach to hyperparallelism, our solution delivers numbers that beat every one of these competitors at a rack per rack unit basis, and we deliver 20 million IOPS at 4 rack units. 90 gigabytes a second read for file, 80 gigabytes a second read for write. Our numbers deliver impressive results, block, file, and object. This linear scale-out world driven by the hyperparallel applications is driving customers to ask for more flexible storage. And we're delivering that through our high performance ability and our linear scalability, and because these are the key to the flexibility. You can start small and grow big. Any one of our controllers can support either block, file, or object. So our array can be configured as all block, file, or object, or all block, all file, all object, or anything in between, all giving that consistent, predictable, and scalable performance as these controllers scale out. In fact, one of our customers is leveraging our ability to now do S3 by adding a couple of our storage controllers to be able to deliver some cloud-like S3 high-performance storage on an existing array. And as they move forward, they believe they will buy a dedicated array as their needs are dedicated to all object, giving them that flexibility to start small and grow big. Remember, all that performance and ultra-low latency, what can I do with that? Well, what it does is it gives you flexibility, and that flexibility is to scale in place, to start small and grow big, and grow that platform as your business needs grow. You can scale our system independently. If you need more performance, scale performance. If you need more capacity, scale capacity. You may start our system with a couple line cards or 4 controllers running block. You may then need more performance because you're now going to run file, so add more line cards to increase your performance. You can then add capacity to both of those at the same time. You may then choose that I need more performance because I'm going to add more object protocols, so increase my performance. And then you could add more capacity. You could then just add more performance again and add more capacity independently, or any combination in between. Allows us to linearly scale and give you that consistent, predictable high performance with ultra low latency. Remember, whether it's block, file, or object, or any combination in between. So what makes Pavilion unique and different? It really comes down to question of what does a few things do for you? What does high performance, what does scalability, what does ultra low latency in your storage do for you if you can do that with block, file, and object? First, it provides flexibility and choice. It provides more servers, more VMs, more application densities on the exact same hardware. In other words, you can do more with less. It provides consistent, predictable, scalable high performance. It helps your applications run better. It enables those modern scale-out apps to scale more linearly and more consistently. That improves your efficiencies. Whether that's the ability to move from servers with direct attached storage to shared and all the efficiencies that enable that. Getting similar, better performance in that environment and it's similar, better latency. It leverages the efficiencies of centralized storage and of utilization and management, and all with the storage services you expect, like thin provisioning, snapshot, encryption, etc. It enables those modern clouds, VMware and Kubernetes, to scale linearly as storage capacity increases. That enables consistent, predictable virtual machine performance. All of this at fair or market competitive prices of a typical all-flash or all NVMe flash array. You don't pay a premium with Pavilion for high performance, low latency, and ultra scalability, block, file, or object. To learn more about us, check out our website at pavilion.io, or of course, call or email us. Thank you.